Chapter 2, Part 3, Newton's first law. Newton is our famous scientist who developed the branch or the topic of mechanics. Newton was born in 1642 and died in 1727. Newton is famous for his laws of motion. In this part, we study Newton's first law of motion, or what's called the law of inertia. In fact, the first law of motion is simply a restatement of Galileo's idea of inertia. One way to say the first law of motion is to say that every object continues in its state of rest or of moving with a constant speed in a straight line unless there is a force acted upon the object. Say it differently. If there is no external force acting on an object, then the object will keep its state of motion. If it is at rest, it will remain at rest. If it is moving, it will keep moving with the same speed in a straight line. Say it differently. Objects cannot change their state of motion by themselves. This is the idea of inertia. Inertia is a property of an object to resist change in motion. So Newton's first law is really just a restatement of Galileo's idea that a force is not needed to keep an object moving. Once an object is moving in a force-free environment, it will keep moving in a straight line indefinitely. Inertia is a property of an object. However, a heavy object will resist change in motion more than light objects. You're all familiar with the fact that it's much harder to push a heavy table than a light one. Now, how do we quantify inertia? Newton introduces the concept of mass as a measurement of inertia. So heavy objects, they have more mass, or let's say they have a bigger inertia than light ones. So mass is used as a measure of inertia, and you all know that mass is measured in units of kilogram, abbreviated as kg. Question: a force of gravity between the sun and its planets holds the planets in orbit around the sun. Now, what happens if the force of gravity suddenly disappears? So the force suddenly disappears. The question is, what would happen to the paths or to the planets in motion? Think about it. Well, if the force disappears, then according to Newton's first law of motion, objects will keep moving with the same speed in a straight line. More examples on inertia. Imagine you are sitting in a bus that's moving smoothly on a straight road, keeping the same speed. Now, what do you feel inside the bus? Do you feel moving? Can you eat and drink easily? Can you stand up or jump? The answer is yes. Do you feel any different from being at rest? Probably not. Now, what happens if the driver suddenly pushes on the gas pedal? Well, in this case, you would feel something wrong happening inside the bus. As the driver pushes on the gas pedal, trying to accelerate or to increase the speed of the bus, your body doesn't like that. Your body would like to keep moving with the same speed. So as the bus starts to moving forward, you will feel your body is going backward because of inertia. Next question, what would happen if the driver pushes on the brakes? Well, in this case, as the driver pushes on the brakes, trying to slow the bus, that's to decrease the speed, your body doesn't like that. Your body likes to keep moving with the same speed, and that explains why your body feels like going forward. What would happen if the driver takes an exit on the road? I will leave this to you to think about it, and we will discuss it in a class. These are other examples of inertia, and we will discuss all of them in class.